Hello children, we begin with problem set 6. First question, choose the correct alternative answer and fill in the blanks. Question number 1, radius of a circle is 10 centimeter and distance of a chord from the center is 6 centimeter. Hence the length of the chord is. We have solved these kind of questions in our exercise. I have drawn the figure, I'll show it to you. We are supposed to be doing it like this. You don't have to show the working. You can do it in rough and tick mark the answer. So the question is, the radius is given 10 centimeter. The distance from the center to the chord is 6 centimeter. You have to find the length of the chord. So 10 square minus 6 square. 100 minus 36, 64. So BM is 8 and therefore AB is 2 into 8, 16 centimeter. Therefore the correct option is A. In your question paper, when you get questions like this, you need to write the correct alternative. Now, for example, in this case, you are going to write the answer as capital A. Okay. Second, the point of concurrence of all angle bisectors of a triangle is called the incenter. That is option C. Third, the circle which passes through all the vertices of a triangle is called circumcircle. Option A. Fourth one, length of a chord of a circle is 24 centimeter. If the distance of the chord from the center is 5 centimeter, then the radius of that circle is. Now length is 24. That means half of it is 12. The radius is, the distance is 5. So that's 12 square plus 5 square, right? To find the radius, that's the hypotenuse. So 12 square plus 5 square, 144 plus 25, 169, root 169. Your answer comes 13 centimeter. You can solve it in rough and get your answer. It is very similar to all the questions you have done in our exercise. Okay. Next question number 5. The length of the longest chord of the circle with radius 2.9 centimeter is. We know that the longest chord of a circle is the diameter. So if radius is 2.9, diameter will be double that of the radius. So 2.9 into 2, that is 5.8 centimeter, option D. Question number 6. Radius of a circle with center O is 4 centimeter. If length of OP equal to 4.2 centimeter, say where point P will lie. So the radius is 4. The distance from the center to the point is 4.2. That means it's definitely greater than the radius. So where will the point lie? Is it on the center? Is it inside the circle? Is it outside the circle or on the circle? Definitely it is outside the circle because it is more than the radius. So option C is the correct answer. 7th question. The lengths of parallel chords which are on opposite sides of the center of a circle are 6 centimeter and 8 centimeter. If the radius of the circle is 5 centimeter, then the distance between these chords is. So this is how the figure is. There is a chord AB which is 6 centimeter, so half of it is 3. Another chord 4 centimeter, half of it is 4. The radius for the circle is 5. You have to find the distance between the two chords. Pythagoras theorem, 5 square minus 3 square, 25 minus 9, 16, root 16, this distance is 4. Same way 5 square minus 4 square, 25 minus 16 is 9, root 9 is 3. So 4 plus 3, your answer is 7 centimeter. So that's option D, 7 centimeter. Okay. So that's about question number 1, MCQs. Now question number 2 is not there for you. That has been deleted from your syllabus for this year. Okay. Question number 2 is not there. Third question, construct triangle NTS where NT equal to 5.7 centimeter, TS is 7.5 centimeter, angle NTS is 110 and draw the incircle and the circumcircle. It's very similar to what we have done. I'll show you the rough figure. So you will draw NT which is 5.7 centimeter. Keeping the protractor at T, you will measure 110 degrees. So 90 is a line which is perpendicular here. So more than 90, 100, 110 will lie somewhere here. TS is 7.5. So take your compass, measure 7.5 centimeter with the help of a scale. Keep the steel point at T, cut an arc 7.5 centimeter in length. Join NS. So you have a triangle NTS with the required conditions. Now you will draw the incircle as well as the circumcircle. So I have told you how to do it. For incircle, draw to any two angle bisectors, draw the perpendicular, with that as the radius draw the circle, you get an incircle touching all the three sides. Then for the circumcircle, you are going to draw the perpendicular bisectors for any two sides. The point where the two perpendicular bisectors meet, that is your circumcenter. That point as the center, any of the vertices, that will be the radius. Draw a circle which will pass through all the three vertices, which will be your circumcircle. Okay. Next we go to question number 4. Question number 4. In the figure, C is the center of the circle. Segment QT is the diameter. So C is the center, segment QT is the diameter. CT is equal to 13. This distance is equal to 13. CP equal to 5. CP is equal to 5. This distance is 5. Find the length of the chord RS. You are supposed to find out this distance RS. Now if CT equal to 13, that means it is the radius. That is also equal to CS. This is also the radius, which is 13. Now this is 13, this is 5. Using Pythagoras theorem, I'll find out what is PS. Double it to get the length of the chord. So CT equal to CS is 13. So using Pythagoras theorem, when I find this out, I get SP is equal to 12. Double of 12, 24 centimeter, 24 units is the distance of the chord RS. Okay. So that's question number 4. Question number 5. This is the figure. In the figure, P is the center of the circle. Chord AB and chord CD intersect at the point E. If angle AEP equal to angle congruent to angle DEP, that means this angle AEP and DEP are congruent to each other. Prove that AB equal to CD. The two chords are congruent. This is what you have to prove. So for construction, we draw segment PM which is perpendicular to the chord AB. So A dash, M dash, B, all 3 points lie on the same straight line. PN is perpendicular to chord CD, C dash, N dash, D. Now for the proof, take these two triangles PME and take triangle PNE. Side PE is congruent to side PE, common side. Angle PME equal to angle PNE, which is equal to 90 degrees by construction. Angle PEM congruent to angle PEN, that is given. Okay. Construction here. Then, therefore, the two triangles are congruent by SAA test. So this is the side angle. So by SAA test, the two triangles are congruent. Therefore, segment PM congruent to segment PN, CSCT. Now, since these two perpendiculars are congruent to each other, you have chord AB congruent to chord CD. The reason being, in a circle, if the chords are equidistant from the center, then they are congruent. So if you have two chords which are equidistant from the center, P is the center of the circle, both of them are at equal distances from the center, then the two chords are congruent to each other. Okay, that's the answer for the 5th question. The last question, number 6. In the figure, CD is the diameter. CD is the diameter of the circle with center O. Diameter CD is perpendicular to the chord AB. So both these angles are 90 degrees. Show that triangle ABC is an isosceles triangle. So the proof, you have OE perpendicular to AB. C dash, O dash, E dash, D. They are all in a straight line. You have AE is equal to BE. Reason, the perpendicular drawn from the center of a circle to a chord bisects the chord. Therefore, AE is equal to BE. Now take triangle AEC and triangle BEC. You have CE equal to CE, common side. You have AE equal to BE from the reason that we just gave. And you have angle AEC equal to angle BEC, which is 90 degrees. Therefore, the two triangles are congruent by SAS test. And hence, segment CA congruent to segment CB by CSCT. Therefore, the triangle ABC is isosceles. Okay. So, This is how we prove question number 6. So with this, children, we finish with the problem set. Problem set of lesson number 6, that is circle. Okay, I want all of you to be writing these exercises and the problem set in your classwork. You will be asked to submit your classworks with the portion for the second term completely written neatly, and so children, those who have not done, see that you complete it neatly, the portion for the second term. Now, at least for geometry, the portion for the second term is lesson number 4, 5, 6, 7, 8. Lesson number 4 is construction of triangles. Lesson number 5 is quadrilaterals. Lesson number 6, circle. 7, coordinate geometry, and 8 is trigonometry. Okay, so see that the portion is completed in your class workbooks before your submission. So see that you write it. Okay, that's all. Thank you, children.